what are some of the most promising commercial applications of onboard manufacturing in space, and how can companies and maybe some of the people who are attending here, if they're looking for those opportunities, how they can capitalize on those opportunities? So whoever would like to highlight that. Yes, Virgil?
So I think I can start with a very broad and high-level introduction to onboard manufacturing. Onboard manufacturing capabilities can open a brand new world of the space industry, and it can offer a range of commercial applications that have the potential to transform our vision of the space industry by bringing new concepts such as space tourism, where we can enable the production of customized components and equipment for space tourism, spacesuits, habitats, and spacecraft. Also, it can open the gate for space mining to allow the production and the transformation of resources of mining equipment and components in space, so to reduce the need to launch heavy equipment from Earth. It can also support the construction of space habitats and infrastructure. It can open a new gate for satellite manufacturing and repair, on-orbit repairing. And finally, it can support the research and development to enable scientists and researchers to conduct experiments and develop new technologies in space. So to capitalize on this opportunity, we need to change our mindsets. The previous space industry were mainly based on individual, and right now, with this change of paradigm, we need to have a better collaboration. So we need to find the right partners, find the right collaboration with the institution, and play amongst industry and institution hand by hand and this collaboration will unfold new business opportunities, and that will try to answer unidentified challenges.
Thank you, Virgil. So as I see, nobody would like to add nothing on top of that, so we're just going to move on to it.
Let's give it a pause, Martin. Let's give it a pause.
Go ahead, Gonzalo.
Okay? Because the question might not be in space manufacturing. The question is, what is the problem that we are trying to solve? That's the first question. And in space manufacturing just potentially solves something that is make it, not take it. You know, it's that instead of, you know, and this is the challenge. Is this one is the moment you have 100-ton daily flights into LEO, do you really need in space manufacturing? You might need in space assembly. You might need to rethink manufacturing as a whole. So what I'm saying is that this is true, but it does depend on the capabilities on the ground, because it's you need to think of the whole end-to-end ecosystem. I'll give you one thing that I see a panelist in here. So I want to open up with that one, because I think as I was looking into mass to orbit and to the different locations and potential applications, and I was like, okay, this is a trivial problem, correct? When the Portuguese sailed the world, they took 3 ships. Sometimes there were others, like, you need cargo, guys. You need cargo to build the thing. That's it. And the way that you build the thing is use the resources that are there. But so there is something over there that we need to think about in terms of the mass to orbit. The second thing that I would like also to ask, and since we are here, is someone in here picked up a concept that I see in here, Paul Camus from Space Pharma, that is, they started to have the first, if you come from the auto industry like myself, the first contract manufacturing in space. That is, okay, here is a facility in space that you guys can use. And I was like, that's a brilliant idea, because it allows you less investment, less mass to orbit. So it's picking up the small things right now that you can use the existing hardware, the International Space Station, and then banking on it. So that's, if you like a spur into the economics of it, that's one spur. All the other ones, I think we really need to have a good conversation on what we want to assemble and why. Okay, so that's what I would like to add.
Yeah, if I could add on to that one. Yeah, but so although this is not my area of expertise in terms of biotechnology, I think that would have a great commercial value because when we do think of the tissue culture, I know that there is a huge market onto that one, pharmacy and tissue culture or biotechnology side. One of the main reason is because of the vacuum conditions and space. It is easier to cultivate organs and tissues so that it's less it's less prone to contamination. I think that is also one of the areas, at least at the moment, where it is seeing a lot of traction in terms of commercialization.
Thank you, Prashia. So also go ahead, Mohit.
Yeah, hi. So just from the Interstellar's background, so what we are doing. So even as an introduction that we, in terms of manufacturing, we have to look at two aspects. So which is manufacturing for Earth, in which we can create materials in space which are beneficial to make use of space environment and bring it back to Earth. So basically, which is not possible to make on Earth because of the kind of space environment they can get in space. And another is space for spaceless structure that most of the people were talking about. If it is really needed, is in-orbit assembly, or is it 3D printing, or what kind of thing is like? Is it additive manufacturing, or we want to take it to from orbit to Moon, Mars, or beyond? So that's the kind of thing. So we have to like distribute these two things in a different way. If we are doing manufacturing or we are doing research, is it for Earth or is it for space?
Yeah, actually, if I can intervene, at Space Pharma, we have decided on the one hand to do short-term commercial use of space, which means that and on the one hand, we want something to do in the short term, and the other hand, we want it to be applicable for humankind in the short term. That's why our main objective in the company is to develop new therapies. So new therapies, either through new drugs or through new organs that we will build in space. But our priority, what we believe is the most urgent, on the one hand, because of so many diseases which don't have a solution. And on the other hand, because we don't need to bring tons in order to be able to develop very advanced drugs. We have selected the pharma as our first priority. Our lab is able to do other things, but as the name of the company shows, for us, it's a priority. And we are tackling that today. We plan to send our first factory in orbit to produce specific drugs for which we will be the customer. Most of the time, we provide our platform as a service provider, our miniaturized laboratory, but we can also be the customer. And we will launch our first factory at the end of 2024. And that's to do really in orbit production. So time scale is shortening thanks to availability of new technologies like SpaceX, of course, reusable launchers, reusable labs that we have, remotely controlled laboratory. We don't need astronauts. We can do everything from our application that we develop. We can modify the protocol in real time, and we believe this is probably the first domain which is gonna mature in terms of in-space manufacturing. That's our feeling, at least.
Thank you for the answers. The following question here, as again, we talked about, a little bit, resources, and again, looking from different perspectives. I guess that's for today's panel, we'd like to do that, just look from a different angles. And one of those angles would be also, how can space-based manufacturing be more sustainable? As one of the themes that for this year, we have obviously sustainability, and now with increasing launch rates. And again, as Gonzalo kind of talked about, we have a lot of things going into space. So, and now both in terms of resource utilization and waste reduction. So how can space-based manufacturing be more sustainable? Thank you.
Maybe I can take this one. Hi, Marco Piscaccio from Azimuth Space. We've been involved in more than 10 projects for ESA in terms of advanced manufacturing, additive manufacturing on orbit and in space. And 2 projects had the focus on recycling. So this is the way forward. It's as Gonzalo said, it doesn't make sense to say, okay, we can 3D print whatever in space, so let's do it. It doesn't make sense. There are some cheaper ways to build stuff on Earth and then launch them into space, but for some applications and some products, it makes much more sense to build them in orbit. And for example, once the life cycle of these, let's say, structures or satellites or parts, they fulfill their duty, we recycle them. So we shouldn't just look at the technology as a standalone technology, for example, additive manufacturing in space or advanced manufacturing, but we should look at the complete ecosystem. So of course, the additive manufacturing or advanced manufacturing, however you want to call it, or onboard manufacturing, it's a building block of a whole ecosystem. You also have to think about how to recycle these parts, and this is what we did in one project. For example, together with OHB, Be Very Creative and Active Space, we we constructed the first 3D printer for PEEK, so thermoplastic, that can print both in microgravity and in vacuum. It was a painstakingly process to develop this, but the printer can really print now parts. And what we showed now is that we can destroy these parts after we use them and reuse that material over and over again. I mean, not over again until the end, but there are a couple of cycles that we can reuse until it loses the material properties and we can no longer print it. But this is the way forward to sustainability. And this is how we reduce also the costs of launch and resupply with feedstock or material to space. This is at least what we learned from these projects for ESA that we concluded. You can find the literature. The project is called Urban.
Go on, Virgil.
Yes, and I will continue. I totally agree with you, Marco. We shouldn't have this aspect of sustainability on a very specific technology-based, but also more on a concept and a change of our vision. So the ICASI project is part of the Space Generation Advisory Council in the project group Space Safety and Sustainability. And it highlights that through on-orbit servicing and in space manufacturing, we could also ensuring a fair access to space to amongst all actors. Once a technology is mastered and developed, it could serve other actors, especially such as academies and researchers who usually don't have enough resources to send an experiment in space. They could use already existing infrastructure, already existing and installed technology to demonstrate new concepts that could be used later for the space industry.
Go ahead, Gonzalo.
Yeah, I want to throw a wrench in here. Okay, I want to throw a wrench because of this. We talk about in space manufacturing, but to be fair, to be correct, we can only do that in one place. It's the International Space Station. There is, of course, the Chinese space station. You know what's the cycle time to put something up there and bring it back? I'm talking about organ tissue. And I work in that extensively, so I know the ins and outs of the ISS. From the moment you submit a proposal until you prepare an annual experiment on Earth, make it up there, have the astronauts do a thing that is a researcher that needs to do, kind of a weird thing, correct? Like, yeah, these guys are highly trained, but they are not scientists. So the wrench is this. The cycle time is roughly 3 years. They say, what's the business problem that stands 3 years? Very little of them, okay? So we need to find a way to enlarge the flow, meaning we need to have more things being fabricated on space, but with a shorter cycle time. And I have data and prepared something for the ISS 2 years ago to shorten the cycle time from 3 years to 3 months. And it's possible, okay? From the moment you want something in here, bring it up there and bringing it down with all the reporting and a set of other important things that need to happen. So the wrench is this. If we're going to do in space manufacturing, we need to do it. meaning we need to have stuff up there. It's like space robotics. We can talk about it, but we don't have anything up there. Now we have a tug now that moves around. We need to have thousands of objects that build things, or one object that builds thousands of things. Without that, we are talking in the early days of automotive manufacturing, where no one understood a piece of this. So there are many good news, many good news in terms of their technology already being proven, and the set of the new space stations coming in that are likely to do beachheads like the one from Space Pharma, or likely to do beachheads on 3D printing for structures. And I've got a couple of other sectors that I'm working on. So my question is, yeah, this is all possible, but what's the timeline? And will it be relevant to that timeline when we get there?
Yeah, maybe I can add a few things. Gonzalo, I am fully agreeing with you about the time scale in general. We have found a solution, some kind of solution for Space Pharma, not the solution because it's not applicable to everybody, but because we are a commercial company, we have taken the risk to reserve flights in advance on the ISS, which means that, for instance, just to give you an example, which is quite interesting, during our flight, one of our flight last year, we embarked 3 customers in our lab. The last of the 3, we started to talk to him 4 months before being in space, and we brought him the products 10 days after being in space. So the flight was 10 days long. So in 4 months, we did the full cycle. Why? Because we had reserved a certain number of seats, and we can do that only because we are commercial. And so this is a trend that you're right. We are now starting to we have reserved already place on the Space Rider, which is a mini space shuttle of European Space Agency. We are talking with Dream Chaser, we are talking with Orbital Reef, with Axiom, and so on. So today we have opportunities which are opening following the ISS, which will be too limited, and anyway it will finish in 2030. And that's the right time right now to start, for people who want to do in space manufacturing, to start preparing and reserving space. But it's a risk. It's definitely a risk, and you have to feel confident enough in your business model and your customers you can bring in. But you're right. Today, for 99% of the people who want to go to space, that's the time scale. And for all academy and for all, it's a very long time scale.
Gonzalo,
Yeah.
maybe I can. Sorry, Mohit.
Just go ahead.
I'll be
Go ahead.
really fast. Gonzalo, you're right. We also got selected from ESA to send our new technology development in space, and probably it was selected last year or the year before. This year, hopefully it will be launched, and we'll get them back next year. Hopefully, if everything goes with the Bartolomeo. But this is also true what Paul said. This is from the government backed. If you go, I know now that there are a lot of startups. We've been discussing also with them to test our 3D printer in space. For example, there is Sidus Space, there is the Exploration Company, there is also Space Dots, and they are raising serious capital, which shows you that the industry really saw that they can make it faster than the government, and that there is money in it. And these 3 years are getting shorter and shorter. Maybe, I don't know, maybe in 5 years it will take only 6 months from contract signature if you have the money. But this is the way of progress. If you see what was it, Columbus needed what, 10 days to reach America, 10 weeks to reach America, 2.5 months. This is, you can sit in a plane from today and be at the same day in America. It takes, the progress is faster and faster, and I do believe that these companies have a viable technical solution that can really fulfill your need. You want in 6 months? Sure, they can do it if you have the money.
Yeah, just to add up on that, Marco. So that was a wonderful point that you make. And thank you, Carlo, for raising that there's just International Space Station and the timeline is too high. So that's what we are solving basically at Interstellar. So we also have like our dedicated platform for research and manufacturing. So we have proposed, so we are developing a spacecraft system which is quite efficient, and it is a dedicated uncrewed platform. So we are kind of removing the presence of humans and making it more efficient. So that's what we are building. So we would be able to potentially serve all of you guys, but that's what we are looking at, and I think that's the best way of approaching manufacturing, because if you have a dedicated timeline, if you don't have to waste so much time in terms of developing by the time the business case is lost, and also you have to have more reliable and efficient service, and also return capabilities. That's what is important. And while we are maintaining our orbital factory in orbit, so it's a kind of a mini space station, but it's a very, very small spacecraft, which kind of maintains the factory in orbit. So we would be able to serve it in orbit. So that's what we are focusing on. And in addition to like the point that you raised for sustainability, Martina, so we also did like one of the projects which was funded by UK Space Agency. It was a sprint project last year, and it focused on space debris recycling. So that's a quite far ahead. But in terms of what we looked at is like capturing the space debris. That was looked by another company and university. And what we created is like a very interesting 6 to 7 step process in a space station, and in which we can disintegrate satellite, make use of the potential material, mostly aluminum that we use as a case, and make it into something bigger structures in space through the factory. So yeah, just wanted to shadow up on that.
Thank you all for the answers. And as we discussing here today about space stations and onboard manufacturing, a couple of words have been thrown around today for the people who probably never heard about anything about space stations or onboard manufacturing. So it's 3D printing and additive manufacturing. So maybe some of you can comment, what roles do 3D printing and additive manufacturing play in space stations and onboard manufacturing, and how are these technologies being adapted for use in space?
Maybe I can start with the basic topic about the 3D printing. I think on Earth, we have like very clear picture on how 3D printing works, or how the practical interaction between, when we generally talk about 3D printing, there is, if we were to divide the process itself, we could say that there is solid 3D printing, liquid 3D printing, and powder-based 3D printing. And when we do talk about in space, the interaction between the liquid particles and say laser, when we are using liquid particles and laser as a 3D printing technology, or solid particles in the laser for that matter, we need to understand how these particles interact initially, and how we can actually process it to create a full product. So that is, I think, something that we need to research. And at least as far as I know, so far, there's only been plastic 3D printing that's been demonstrated in space, not really the metal 3D printing. So there's a lot of research that still needs to be understood properly on how the heat transfer that's happening between these particles and the instrument itself, and how is it contributing to the manufacturing process.
Thank you, Vishya. So if nobody would like to add anything to that, I have a follow-up question that kind of ties into this as well. Talking about 3D printing or additive manufacturing. So maybe somebody can comment about new materials and new manufacturing techniques that are being developed specifically for use in space station onboard manufacturing, and how do these differ from these traditionally used manufacturing processes?
I think David explained something around that. I can help on that. We need to see this on why do we really want to build stuff up there? I mean, like, man, it's weightlessness, impeccable, correct? We have radiation that can even help us. That's like turning the environment to help us to do stuff. That's something that we cannot. We can build perfect crystals in the International Space Station. We can have depositing processes that allows us to create human tissues with a level of flow that is impossible on Earth. So all the manufacturing processes have to do with the environment that they are allocated to. And this is really important to get, because we do not, if we try to replicate gravity, we have a problem. Like we know the maths, correct? We know that we need something like 3 kilometers down the line with a big slingshot turning around. That stuff is not going to work. Well, at least not right now. So what I'm saying is, to be precise, in terms of the 3D manufacturing, you have, and I made, well, we all did some research on that, but essentially there are fiber optics for manufacturing in space to get that specific, perfect type of raw material, crystal growth and electrophoresis, and specific, I would say, R&D experiments that deal with microgravity. So all of them utilize the unique characteristics of space, and that's the mindset. But why is that important? Because currently we spend $1.8 billion per year in the International Space Station just for operations and research. So put that in your business plan, okay? That's what I'm doing. Like, oh, okay, this costs, it's just OPEX. I'm not talking about how much does it cost to build. But this was the ISS, the largest, more expensive ever engineering thing on Earth. And it works. So pick the environment, pick $1.8 billion, put in our business case, derive the manufacturing techniques from there. And and then it's possible.
Thank you, Gonzalo. In terms of potential applications for onboard manufacturing in space, it's, again, for those who are being used and in terms of providing needs for astronauts, as we're talking about, obviously we have people in there, it's not going to be all fully automated. So how those manufacturing applications could be used to provide and solve the needs of the astronauts, and also support the further exploration and colonization of space.
Yeah, your question is how one relates to the other in some way. Actually, when you talk about life sciences, for instance, and life sciences is, for instance, of course, the most classical is pharma, but you have nutrition and you have food like cultivated meat, the experiment which was flying with Salad Farms. Most of the applications which are being developed now in life science in general are applicable both for Earth and for exploration out of the Earth. Either it's medicine that we are working on synthesizing medicine in orbit for astronauts on long journey to Mars. We are working on as people have done already in different places, raising plants and cultivating meat in space, which will be useful for people traveling in interplanetary space. But the relationship between what is being developed for astronauts or what is being developed on Earth is very, very close. Really, the links are extremely rich between the two applications. In Space Pharma, we have as main objective health on Earth, but almost everything we are doing will have an impact on the physiology of astronauts and the way they will be able to use therapies on their way. So I think the two domains are very, very, very narrowly related, really.
Thank you, Paul. Maybe what about some of the pressing ethical and safety concerns associated with onboard manufacturing in space? Maybe you can also, some of you, discuss how some of those, once again, pressing ethical and safety concerns are now being addressed by engineers and policymakers. Go ahead, Virgil.
I think in terms of safety, what we have, the legacy of safety in design and operation for space has been derived after the accident of the space shuttles, and everything has been based on nuclear. So we take the most hazardous activities in space and we try to translate them for space. So for this, we can have several kind of risk assessments. We have several tools to quantify risk, highlight the critical part of the system, implement mitigation on a system level, but also on an operational design. And then because space is harsh, I would say that we have a lot of materials, a lot of manufacturing process that we can use and that has been developed. We have hundreds of years of legacy of what tools, what materials needs to be used in order to fulfill their purpose safely. And also monitoring, preventing any kind of hazard, any kind of malfunction term, and implement redundancy, replace the parts before they are defected. For this, we have a lot of legacy already on Earth that we just need to adapt to space.
Thank you, Virgil. Gonzalo, go ahead.
I want to up two different threads on this competition. One of them is NASA is still working on the key 25 risks for human space flight. That's pretty straightforward. No, it's not pretty straightforward, because if it was straightforward, they would have sorted out. And one of them is the risk. It was my daughter. She said, "Like, we need food now." Okay, and this is one of the problems. You guys have seen the face of excitement when the Crew Dragon brought ice cream to the ISS. Like, wow! Human needs are not just the dehydrated food. It's when you start having with supplies that have to do with the fact that these guys are there isolated for a long time. So bringing food that is different, having with supply missions doing that, in a constant basis will change. Of course, American does, the ice cream costed like $9,000 for that piece of thing. But that's where we are right now. So one of the things is, what kind of specific outcomes can we mitigate with the right systems integration architecture? That part is not sorted. It's one of the key risks in the NASA, the 25 risks. So that's one thing that we need to make sure that it's baked in when you pitch to both investors and I've got the list of the 50 resources. If you really dig inside of them, the mitigated ones are not mitigated for deep space flight. And I'm happy to share this with you guys. The second one is, okay, how are we going to rescue people in space? So I think that's going in that direction. You'll see people talk about ISM or ISM, in space manufacturing or in space manufacturing and assembly. And that needs to go in some level and some kind of direction. Do I have the ability to have 24 hours of food, medical supplies right now for a crew that cannot enter Earth? Even if they're on the ISS, imagine the docking model is off. There is no Soyuz there as well. Oh man, I need to put something, and that's the reality. So that type of service is coming in, and I think there is something to try on that. And getting back to the last application of that. Don't send people. Don't send people. It's too hard. It's too difficult. It's send bots before boots, and we have proof. And well, we got a couple of companies in here that they can explain that we send bots and we isolate that to make sure that the business case is successful. So those are three key implications of sending humans. Of course, I'll be an astronaut. I'll be there, but it's going to take. I understand the problem.
Maybe I can make a little comment concerning your question about when you talk about social and ethics. I think there is one topic which might have an impact on our social and ethics vision of the world is the topic of aging. I think within the next few years, through space investigation and space research, we are going to learn much more about aging, and it might have an impact on longevity, and this has a direct impact on social aspects. I was talking about that with some people, and some said, it's great, people are going to live longer. And some other people said, oh no, we are going to work more. And what about our retirement and so on? So it's a real social issue, whether longevity is good or bad, but definitely I believe space is gonna bring breakthrough in understanding aging in the next few years. And this is, of course, the result of already 30 years of studying how all the physiology of the astronauts has been evolving in the space station and elsewhere in space.
Thank you. So while we're approaching an end of this panel, I would like to ask a following question. Overall, again, summarizing what we discussed today, how do you see space station onboard manufacturing capabilities impacting economics of space exploration? And also, as some of you mentioned, there are some serious people raising some serious cash for the project that they have. So maybe you can also talk about the potential long-term benefits of investing in some of these technologies. Go ahead, Marco.
Thank you. So, yes, I wanted to connect with what Gonzalo was saying, and then give you just an insight into one of our projects. This the 3D printer in Peak. Gonzalo, that's true. We tested our 3D printer in our thermal vacuum chamber. So it was cycling, and we printed parts. And one of the problems that we had was calibration. So, for example, we calibrated the 3D printer, the bed and everything, and during, I don't know, the fourth cycle, so imagine being 3 days in a closed thermal vacuum chamber, it shows that it's delaminating, the parts are delaminating from the bed because it wasn't calibrated well enough. So we had to break the thermal vacuum, then open the chamber, calibrate everything, close it, and then restart. As Gonzalo said, we cannot rely on astronauts to do this kind of things in space all the time. So we definitely need robotic hands or help for assembly, for inspection, for monitoring, and also for repairing these small errors that can cause the whole system to fail. This is just to connect what he was saying. About your current question, what I see as a straight line into what we need to do in the future is utilize in situ resources. So, for example, we know that the next step is the Lunar Gateway, or I don't know what it's called now. So the next space station that will orbit the moon, and you have materials in abundance on the moon. You have silica, you have metals, you have oxygen. You can subtract all of the metals that you need from there, so that you can build systems and you can build parts closer than having them sent from Earth. And this is kind of an ecosystem that you can create. We don't have the technologies now. We printed bricks out of regolith simulants on Earth, but it will be totally different in space, and we need to adjust the whole 3D printers that we have for powder bed printing, so that we can print around the moon, let's say, or on a lunar base. But as Gonzalo said, this timeline, I will be super happy if I live through this exploration phase in my lifetime. I'm not super optimistic that we will reach this kind of technologies we see on the TV or in sci-fi movies, that we will have such technology in the next, I don't know, 10 or 20 years, because it gets pushed back because everyone knows space projects, it takes forever to verify and validate what you're building.
Yeah, to add on to your point, that is very nice point, because at least I've been also working on in situ resource utilization and how space exploration, and on especially particularly for lunar missions, how can it be improved, or what is the technology demonstration we could do on board or in the low Earth orbit, so that we can achieve certain TRL and then reach lunar surface, for that matter. That way, when we talk about in situ resource utilization, there is like really there's a huge gap, as in like if we were to say, even if we are extracting those materials on surface of lunar surface, we still like the instruments that is applicable on Earth is not really directly applicable on surface of Moon. Because we take gravity into consideration, there is like so many instruments that work on Earth's gravity is not really applicable there. In terms of even rotary systems, like say even drilling machines, even as simple as drilling machines cannot really work on lunar surface directly. So that way I see that we need to demonstrate, or we need to do certain research work in terms of how we can achieve the technology readiness level on first to the low Earth orbit, and then reach to the, extend our missions to be more sustainable and more successful on the lunar surface, or in terms of any space exploration bodies.